So this is a typical exam question. They'll usually split it up into parts because this is quite a long method to do. Okay, so for part A, like I keep saying, I always find it useful to draw a diagram. So I'm going to draw a circle, and I'm not going to worry about the axes. In fact, I'm not going to worry about the scale at all. I'm just going to say that A is up here, B is here, and C is here, and the centre's about here. They're not going to mark it on the diagram. This is just to help me. I realise that it's not to scale at all with the points. So what we need to do, remember, is we need to find two perpendicular bisectors from either AB, BC, or AC. It doesn't matter which two out of the three we use. So to start with, I'm just going to do AB, and I'm going to find the perpendicular bisector of AB. So to do this, the first thing that we need to do is find the gradient of AB. So the gradient of AB is going to be 5 minus 1 over minus 12 minus 14. And if we put that into a calculator, we'll find that's equal to 2. So therefore, the gradient of the perpendicular bisector is going to be the negative reciprocal of that. So it's going to be minus a half, and this is the gradient of the perpendicular bisector we're working with. And we need to know a point on the perpendicular bisector, which would be the midpoint of A and B. So the midpoint will be, if we're using these 2 points, remember, A and B. So for the x coordinate, it's going to be the midpoint of minus 14 and minus 12, which is going to be minus 13, and the y coordinate is going to be the midpoint of 1 and 5, which is going to be 3. So this is the midpoint, and this is the point on the perpendicular bisector that we're going to use. So we're going to use the equation of the straight line y minus y1 is equal to mx minus x1, and we can sub the values in. So it's going to be y minus 3 is equal to m, which is minus a half, x plus 13, and this is the equation of the perpendicular bisector of AB. Okay, so now we need to find another perpendicular bisector. We can either do AC or BC, it doesn't matter. I'm just going to do AC, and we need to find the perpendicular bisector of this. So to do this, we need to find the gradient of AC, which is equal to 6 minus 1 over 1 minus 14. We should put that into a calculator, equal to 1 over 3. So therefore, the gradient of the perpendicular bisector is going to be the negative reciprocal of 1 over 3, which is going to be minus 3. And this is the gradient that we're going to work with. And then we need to find a point on the perpendicular bisector, which is going to be the midpoint of A and C. And the midpoint of A and C is equal to the x-coordinate. Remember, we're using these 2 points here. The x-coordinate, the midpoint of, if we use the method that I talked about before with adding and minusing the same values, so the midpoint of minus 14 and 1 is the same as the midpoint of 0 and minus 13, and the midpoint of that is minus 13 over 2, and for the y coordinate, it's going to be the midpoint of 1 and 6, which is the same as the midpoint as 3 and 4, so the midpoint is going to be 3.5, which is just 7 over 2. Although again, if you want to use the formula for finding the midpoint, then that's fine as well. So now we've got a point on the perpendicular bisector, so we can write the equation of the perpendicular bisector as y minus 7 over 2 is equal to minus 3x plus 13 over 2, and this is the equation that we're going to use. Okay, so now we have the two equations for the perpendicular bisectors. We're going to find the point of intersection of them, which will give us the centre. So I'm going to expand both the brackets of both of them. So the top one is going to be y minus 3 is equal to minus a half x minus 13 over 2, and the bottom one is going to be y minus 7 over 2 is equal to minus 3x minus 39 over 2. We can move the minus 3 and the minus 7 over 2 onto the other side for both to do y is equal to minus half x minus 7 over 2, and the bottom one is going to be y is equal to minus 3x minus 16 if you put it into a calculator. And then we can make these equal to each other as y is the subject of both, so we can do minus a half x minus 7 over 2 is equal to minus 3x minus 16. We can move the minus 3x onto the other side to do 5 over 2 x is equal to, and then on just to save space, you can write out both steps if you want to. We're going to move the minus 7 over 2 onto the other side to make 5 over 2x is equal to minus 25 over 2, and then from this we can do minus 25 over 2 divided by 5 over 2, which means that x is equal to minus 5, and then we can find the value of y by subbing this into one of the equations. It doesn't matter which one, so I'm just going to do the bottom one. So y is equal to minus 3 minus 5 minus 16, which if you put it into a calculator is equal to minus 1. So therefore we know now that the centre of the circle is equal to minus 5 minus 1. These are simultaneous equations up here. If you wanted to check your answers to these, you could put it into the calculator like I've described before. Okay, so part B is to find the equation of the circle. So we've got the centre, so we're halfway there. We just now need to find the radius, which we can do by finding the distance between the centre and either of the 3 points. It doesn't matter which one. I'm just going to do C. So we can do the distance is equal to minus 5 minus 1 squared plus minus 1 minus 6 squared, and if we put this all into a calculator it will come out as root 85. So therefore the radius of the circle is equal to root 85. So therefore we can write the equation of the circle as x plus 5 squared plus y plus 1 squared is equal to the square of root 85, which is just equal to 85. And this is the equation of the circle. To check this answer, what you could do again is to sub the points into the equation as x and y and see if you get 85 out, to check if all the points lie on the circle and therefore you've got the correct answer, and if you do that you'll find this is the case. So I would note down a question like this because as it's on the spec it's extremely likely they might ask you something like it, and especially note kind of this kind of diagram of how to do it with the perpendicular bisectors. So here's a question on triangles and circles properties, so pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for part A, we need to find the centre and the radius of C, and C has this equation here. Now, this form of the equation is not useful to us at all, but remember, we can complete the square in order to get it in the useful form and then easily find the centre and the radius. So to do this, first I'm just going to rearrange it to x squared minus 6x plus y squared plus 4y is equal to 12, just to make it a bit more easier to complete the square. And then we want to complete the square on the two separate parts of the x and y. So if you complete the square on x, it will be x minus 3 squared minus 9, and if we complete the square on the y part, it will be y plus 2 squared minus 4. And that's going to be equal to 12. We can simplify this to x minus 3 squared plus y plus 2 squared minus 13 is equal to 12, and then we can put the 13 onto the other side, the minus 13, to do x minus 3 squared plus y plus 2 squared is equal to 25. And then from this we can say that the centre is equal to 3 minus 2, and that the radius is equal to the square root of 25, which is 5. So for part B, it gives us 2 points, and we need to prove that the line that connects the 2 points, PQ, is the diameter of C, or a diameter of C. Now, at first you might think is that this is one of the questions we talked about before. We have to prove that something is a right angle in order to say that PQ is a diameter, but it doesn't give us any other points. What's interesting about this question is that, as we already know the centre and the radius, this question gets a lot easier. So there are actually 2 ways you can answer this question. The first one is if you just draw a diameter, so let's say this point here is P This point here is Q. If this is the diameter, if you figure out the distance between P and Q, if this is the diameter, this should be double the radius, which will be 10. So therefore, if it is double the radius, therefore you can say that as the distance between P and Q is 10, which is double the radius, therefore we can prove that this is the diameter. So that's the definition of diameter, is it's 2 times the radius. However, there's another way to do this, which I think is a lot easier, or a bit easier anyway, is that if PQ is the diameter, the midpoint of P and Q is going to be the centre. Remember this, the midpoint of the diameter is the centre, so therefore if PQ is a centre, then the midpoint of P and Q will be the centre of the circle. So what we can say is that the midpoints of P and Q is equal to, I'm going to use the formula here because I can't just write 3 minus 2, otherwise that doesn't really show that I've actually worked out anything. So I'm going to use the formula to show that I understand what the midpoint is. So the midpoint is equal to 7 plus minus 1 over 2 for the x-coordinate. Again, I'm writing out the actual formula to show the examiner that I do understand how to figure out the midpoint rather than just writing out 3 minus 2. And then the y-coordinate is going to be 1 plus minus 5 over 2. And then if you put this into a calculator, you will find that this is equal to 3 minus 2, which is equal to the centre. So therefore, remember, for a proof you have to write a sentence. We'll get a bit more into this into chapter 7 about proofs and how to do them properly, but you need to write a sentence. So we'll say, as the midpoint of PQ is the centre, PQ is the diameter. And that is a perfect sentence, and then that is the correct answer. Again, you could do it by the radius technique though, as I said. So for part C, the key of this is just reading the question. So it says that point R lies on the positive y-axis. So point R is going to lie on the positive y-axis, so it's going to be like this, and therefore we can infer that x is going to be equal to 0, as that is the only way that it can lie on this line, is when x is equal to 0. Now something when I first read this, I kind of just presumed this, which is quite stupid of me, is that it says that there's no point in which it actually says that the point R actually lies on the circle. However, we can show that it does, because if the angle PRQ is equal to 90 degrees, if we just sketch a quick diagram, the only way this can be if PQ is the diameter, the only way this can be is if R is on the circumference, because we know about what we talked about before with triangles and circles, that this is going to be 90 degrees if this is the diameter, and this point here is going to be R. So R has to lie on the circumference for the angle PRQ to be equal to 90 degrees, because that's the only position in which it will be 90 degrees, is if it is on the circumference. So how do we figure out what R is? Well, we know that the x-coordinate already, so we're going to call R is equal to 0, and we'll call the y-coordinate, which we don't know yet, we'll just call it y. So we need to find y. Well, the way we can do this is we know the centre as 3 minus 2, and therefore the distance between the centre and R is going to be the radius 5, because remember that the centre, because R is on the circumference, and remember the radius is just the distance between the centre and a point on the circumference, so therefore the distance between 3 minus 2 and R is going to be the radius, which is 5. So if we use a distance formula, D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and all of this square rooted. We can sub in the values and say the square root of, remember we're doing the centre and we're doing R. So for the centre and R, it's going to be 3 minus 0 squared plus minus 2 minus y squared, and all of this is square rooted, and this is going to be equal to 5, because it's going the distance between these points is the radius, which is 5. We can square both sides. We can just write this as 3 squared plus minus 2 minus y squared is equal to 25, so we square both sides. Simplifies to 9, as that's 3 squared, plus, if we expand the brackets, it's going to be y squared plus 4y plus 4 is equal to 25. We can add the 9 and the 4 to get y squared plus 4y plus 13 is equal to 25, and we can bring the 25 onto the other side to make a quadratic equation, y squared plus 4y minus 12 is equal to 0. And then we can solve this, so you can just put it in the calculator if you want to, and if you put it into calculator or just solve it by factorising, etc., you will find that the values for y are equal to 2 and minus 6. So we've got two values, however it says that we need to find the coordinates of r, so therefore there is no point in which it says that there's going to be two values of y. However, we can really quickly see that only one of these is going to be the answer, because it says that it lies on the positive y-axis. So therefore y cannot be equal to minus 6, as therefore this would lie on the negative y-axis. So therefore y is going to be equal to 2. So therefore we can say the coordinates of r is 0, 2. And this is the answer.